Okay, appreciate that, Marco and Richard. Now, okay, so the agenda for the talk today is I'll kick off with a brief summary and introduction about a background to AIV, and this will include the important distinction of two subtypes, the H5 and H7 AIV subtypes, which are the causative agents of notifiable avian disease. They are classified as such because these exist not only in the relatively mild, low pathogenicity forms, but they can mutate to the corresponding high pathogenicity forms, only H5 and H7. I'll talk about AIV poultry surveillance. I'll just summarize that in one slide. Here, the starting point will be the report cases, which are defined. That's our terminology for suspect outbreaks, and that leads to confirmation in the laboratory. Now, although of course outbreaks per se will not be the focus of our presentation, however, the report cases which are confirmed as outbreaks then do lead to actually prompt some outbreak related poultry surveillance. I'll refer to peacetime. Now, we haven't had much of this luxury for virtually 3 years, but we'll note what we have called in the past, peacetime surveillance, which we do try to do as and when possible in the current climate. Scott will then provide some clear examples, which is, all credit to the area where Scott delivers the goods in fighting the outbreaks, but alongside that he has his surveillance examples, and then Scott will conclude with where are we going with all this and a summary. Okay, so if I can just show you a little bit of virology here. It is the only scientific slide you'll be pleased to hear. This is the classic avian influenza virion structure, and I draw your attention to the external antigens. That's the hemagglutinin. Yes, you can see the cursor is showing it. It was shown as the yellow knobs protruding on the outside surface. That's the hemagglutinin, but also the green ones is the neuraminidase. They're HA and NA. They are the external antigens which the immune system sees in birds, provided, of course, the virus has not killed the birds rapidly, as often is the case in chickens and turkeys with highly pathogenic avian influenza. But anyway, we have subtypes of avian influenza, which are determined by the different hemagglutinins and neuraminases. The hemagglutinins go from H1 to H16, and the neuraminases from N1 to N9. So you get all sorts of permutations of these external glycoproteins, which elicit antibody responses, which are an important aspect of some of, say, for example, the serological surveillance we'll be talking about. Now, inside the virus, inside the core of the virus, where I'm moving the cursor now, you can see 8 genetic segments. The shortest one, the largest one, segment number 1, is at the top, and at the bottom you've got segment number 8. The hemagglutinin is encoded here by segment number 4, and the neuraminidase, whatever it is whatever subtype they may be, is encoded by segment 6. So what does happen is that you get reassortment of genetic segments as a mechanism of avian influenza evolution. This is equivalent to shuffling 2 packs of cards and we're taking out 1 packet of card. So this is how the HA and NA segments reassort to produce new subtypes. For example, you can have H5N1, and then it goes through a reassortment event, and you have H5N8. In fact, it happened the other way around. Those of you who have been involved in the outbreaks will know that these are 2 of the infamous players during the last 3 years. Indeed, H5N8 caused us problems before. Now, a little bit of epidemiology here. As Marco explained, the natural reservoir of avian influenza viruses is wild birds. So here I'll focus on the wild anseriforms, the Anatidae, which also include, which is normally where the low pathogenicity forms circulate, and occasionally some strains of low path, some subtypes can transmit onwards either into farmed anseriforms or even into commercial galliforms. This does include all the non-notifiable subtypes, which even though, it's not a primary concern for policy, nevertheless, they can be problematic to industry. We have had economically damaging H4 and H6 outbreaks in the UK within the last decade. These are low path viruses, but there are now strains emerging which do seem to be defying the textbook and are more virulent and aggressive. Now, going back to the H5 and H7 story, in the galliform hosts, so here we have the chickens, this is where the H5 and H7 subtypes may or may not experience a mutation to form the corresponding high path, which can then cause these sorts of devastating outbreaks in commercial galliforms, which I'm sure you're all familiar with. I should add that, yeah, that historically most high paths, H5, H7, cannot transmit back to anseriforms from commercial galliforms. However, the current problem child of these H5NX, because the X stands for could be N8 or N1 or N5, the current H5N1 as we have it at the moment, exemplifies an advantage which this lineage has acquired, whereby it can go back into anseriforms, which can sustain it as a reservoir host, and you have this insidious clockwise circle continuing, which maintains it, and that spells out endemicity, which has been the problem in many parts of East Asia. And of course, this is what we are trying to prevent. So surveillance is the key tool, on the key tools here, which is in the UK and in many European countries. You can divide it up into 3 different approaches. There is syndromic surveillance, which is passive, based on clinical signs, which leads to the report cases. So that's the suspect outbreaks, where 20 oral pharyngeal and 20 cloacal swabs are collected and tested by real-time PCR. And basically that's all I'll say about that. We're not talking about the outbreaks in any sort of detail, but the discovery of the confirmation of an outbreak prompts additional surveillance in order to get evidence which excludes infection, which will include the zone tracing, pre-movements to obtain permission under the statutory conditions, say to move birds, predominantly ducks, and restocking. That last one we may not have much time to go into. There's also the early warning surveillance, which is also known as testing to exclude scheme. And that applies really only to commercial galliform flocks in the UK, and that is used for more ambiguous clinical signs where the field veterinarians are perhaps a little bit reticent, for whatever reason, to declare a report case. It serves as a safety net for syndromic surveillance. So again, that's 20 oral pharyngeal and cloacal swabs tested by AIV PCR, and if these are positive, then they are escalated to a report case with official samples taken as per syndromic surveillance. Then we have the active surveillance. The final approach is we call it the UK Poultry Survey, where we look at a subset of apparently healthy flocks in the UK, which is performed serologically, and then if antibodies are detected here to H5 and H7. So again, it's really looking for evidence of notifiable avian disease, past or present. Restrictions will then be imposed on the premises, and then again it becomes ramped up to an official report case, but with a greater testing numbers of swabs, front end and back end, and 60 sera as well, which are then checked out in the laboratory. I'll just comment about the what we call the peacetime research and validation work, which we do, and which impacts the diagnosis and the surveillance work here. You've already heard from Marco already the example of the H5 HiPath real-time PCR, a very valuable tool that will come up in Scott's slides in a minute. I'll also mention the validation of swab pooling. The colleague from the mathematical department, Mark Arnold, ran one of his famous Bayesian models to underscore the validity of that, and that has proven its value in reality. Okay, so I think that is, yes, and just to underline that this is all impacting all 3 surveillance threads, and indeed those big blue arrows should be double-headed arrows. They should be feeding back from what we learn from the field into our ongoing research work. So without further ado, Scott, if you're all set to take over, and please give me a shout when you need to advance the slides.
Thank you, Marek. So I'd like to go into a bit more detail about each of the surveillance strands. So most of you will be familiar with the surveillance zone testing, where you have your IP, and then you set up your detection and surveillance zones around the IP. So for the actual testing of samples, we actually receive oropharyngeal swabs, and we use the high path H5 detection PCR, which has already been mentioned by Marco and Marek, on pools of 5 swabs. So to give you an idea of numbers, we've actually tested 494 premises in Great Britain from November 2021 through to September 2022, comprising over 12,000 OP swabs. Not actually had any positive results, which is nice. We do a lot of new report cases do occur in EZs or SZs, but we've not actually had any positive surveillance samples from the zonal testing. So next slide, please, Marek.
Sorry, this thing seems to have got stuck. Sorry, there you go.
There you go. So
thank
you. So related to the zonal testing, more recently, we've done what we call pre-movement license testing, where we've had apparently healthy duck premises within IPs, and they want to send the ducks off to the abattoir for slaughter. We have to screen them for influenza. So again, we test pooled oropharyngeal swabs from each epidemiological unit. Over the same time period of I've just mentioned, we've tested 126 epidemiological units by the high path H5 detection PCR, and we've actually had 3 positive cases, which have been escalated to official report cases. So they've gone back to the affected epi unit and resampled, put restrictions on the premises, and resampled 60 oropharyngeal and clavicle swabs. So the 3 positive cases, if you look towards the bottom right-hand corner of the slide, we had the 3 report cases which emanated from the positive pre-movement surveillance. So you can see the middle part of the box. These were the positive pools we had from the pre-license testing, and you can see that even 1 positive pool out of 12, we were able to detect high path H5N1 from the resulting report cases. This is a really good example where the surveillance strand is detecting early infection, which is then officially detected in the subsequent report case. Next slide, please, Marek. Right, so Marek previously mentioned the poultry survey surveillance. So this is our serological surveillance, which we've been doing for a number of years now. And so this slide summarizes the H5 and H7 antibody detection. So towards the left-hand side of the slide, you can see that obviously the current epizootics are affecting the volume of samples we're receiving. So when we were in peacetime in 2018 to 2019, and we had over 250 flocks tested each year with over 4,000 sera. You can see that as we start approaching the epizootic year from 2020 onwards, the number of flocks tested has gone down. Especially in 2022, we only tested 63 flocks, but I guess we were in the peak of the epizootic then. And towards the right-hand side of the slide, you can see in the box that over the period 2018-2020, which you can see was peacetime, we had 1385 positive flocks. So even in peacetime, we are detecting previous exposure to avian influenza in the flocks. But over this summer, so moving down the slide, summer 2023, we've actually had no less than 5. In fact, it's actually 6, but you had one today, 6 positive poultry cases. So we had the 5 non-negative poultry submissions, and they're all among duck and geese flocks. So all 5 were escalated to report case status. 4 of them were actually negative, so we didn't actually detect any viral shedding. So the birds had only had prior exposure to the virus from the antibody response. But one case, ducks in Kent, yielded high path H5N1. So this is the first time we've detected a high path virus from the poultry survey. So again, the survey seems to be working. Next slide, please, Marek. So coming on to the testing to exclude scheme. So this was set up almost 10 years ago on chicken and turkey flocks, where the owners and the vets are detecting a flock and production problem, but it's probably not high path. So we receive the swabs for testing, and positive PCR results are then escalated to report cases. So up to March 2021, we've out of the 45 ETE submissions, we've had 9 low path avian influenza incursions across a range of subtypes. So the scheme has been quite productive. There's been a nice productive uptake. The scheme has also detected 2 avirulent APMV1 outbreaks. So with this data, we think this is the TTE scheme is a really good early warning system for low path avian influenza virus. And it does complement existing surveillance strands. Obviously, the scale of the epizootic we're in at the moment with the high path H5N1, it has scaled back the TTE scheme. So we've not actually had any submissions for over a year now. But once the epizootic dies down, I'm sure the cases will come back. So next slide, please, Mark. So what next with the surveillance? Well, it's the scheme obviously, the surveillance schemes remain important for checking biosecurity in the wake of an outbreak. We think that the surveillance will then move on to things like environmental survival of the virus, which we link to cleansing and disinfection. Again, moving on, that we think the sentinel poultry will be important in surveillance planning, especially on mixed game bird farms. In terms of research gaps, at the moment for the poultry survey, the serology survey, we concentrate on H5 and H7, but it would be good to look at other, what we may term low path serotypes like H4 or H6, because that could be very interesting. And then in terms of the long term, we can be looking at changing prevalence trends. So next slide, please, Marek. So in summary, I'm hoping the presentation has shown you how extensive and diverse the schemes are we use for AIV surveillance. It is a major activity. It's not just all about report cases. Surveillance is a major activity. We do a lot of applied research around surveillance, which is policy driven. We want to improve our diagnostic and surveillance toolbox. So we want, with an improved toolbox, we'll have better surveillance. In terms of the, but it's very important to look at the benefits from research. So through research, we can model AIV incursion, look at transmission efficiencies, look at pathogenesis, and that can all feed into the success of our surveillance programs. And as I said previously, environmental survival and persistence will be very important considerations as well. So can we move on to the final slide, please, Marek? This is just to acknowledge everyone. So there are too many people to mention. We've got all the colleagues in the labs, the field colleagues. In terms of funding, we have our DEFRA core funding, Flu Futures, and we have a BBSRC funding. And thank you for your attention. Thank you.